Hello, everybody. We're talking about rational numbers here and what rational numbers are. So here's the definition. Rational numbers are numbers that can be expressed as a fraction. Example, p over q, where p and q are both integers. So what are integers? Integers are just whole numbers, their opposites, and zero. Examples 1, 2, 3, -1, -2, -3, 0. This is also an integer, negative 142,800. As long as it's a whole number or its opposite or zero, it's an integer. So examples of rational numbers would be like 5/6, right? This is a rational number or an integer over an integer. You could also have 6, right, is a rational number because you could write this as a fraction, 6 over 1, which would make it a fraction, and it is a rational number. So all of the numbers that can be expressed as an integer over another integer would be a rational number, so like negative 2/5. Okay, so now that we have that definition, where do we use fractions, for example? Well, I had this this problem I was working on this weekend. I was building something. It was actually a trebuchet. It's like where you launch things into the air. But I wanted to build the base for it, and I had these boards that were 5 inches wide and 60 inches long, and I wanted to kind of glue them all together to make something that was 30 inches wide. So the way you do that, well, let's say, 5 plus 5 plus 5 is just 5 times the number of boards that I would have. So this is 5 times x. Equals, so I wanted to make it up to 30, right? So I could do what's called the guess and check method. I could say, well, what if I used 5 boards? How much would I have? Well, 5 times 5 is 25. So this is kind of like this is a linear function, right? It's each time it repeatedly adds 5. So this is going to, the rate of change is 5 each time I add 5. So this so let's just guess and check. So 5 times 5 is 25, which does not equal 30, and it's too low, right? So try something bigger. How about 7? 5 times 7 equals 35, but that's too big, right? That's not equal to 30. Too big. So try something in the middle, right? And you guys are probably laughing at me because you probably saw it before I did. That 5 times 6 was 30, right? So this equals 30, so this is what we want, and we say x equals 6 is a solution, right? It's a number that works. So a solution to this problem was say, okay, if I took 6 boards and glued them together, I could make a 30-inch base. Now, that was kind of lucky that it came out exactly, but what if I ended up with I wanted to get to a base that was 32 inches big? Well, I could do the same procedure. So 5 times some number equals 32. So how many of these boards do I need? Well, I could try 6, right? 5 times 6 is 30, which is not equal to 32. That's too low. And I try 7, which I got 35 before, was too big. So it's something between 6 and 7. So if I have a number 6 here and a number 7 here, what's between 6 and 7? Well, it's not an integer, right? But it is some kind of fractional number. How about 6.5, right? So let's try 5 times 6.5. Well, the way you multiply by a decimal, you can stack them like that. So 5 times 5 is 25. 5 times 6 is 30, plus 2 more is 32. So I get 32, and then there's 1 decimal in the question, so 1 decimal in the answer. So it's 32.5, which is too big. It's not equal to 32, right? So I need to go between 6.5 and 6. So I could try, how about 6.4? It seems like it's closer to 6.5 than it is to 6. So I'll try 6.4. 5 times 6.4 is 5 times 4 is 20. 6 times 5 is 30, plus 2 more is 32. one decimal in the question, so 1 in the answer. So I get 32.0. So is 32.0 equal to 32? And the answer is yes, right? If you have $32, you can write it like that, which is just $32, right? So 0.0, any trailing zeros don't really count towards the value. Well, actually, what do these decimals really mean? Decimals are really just tenths, right? So let me grab a fresh sheet of paper. So what are decimals? So if I have 6.4, that means that there are 6 and 4 tenths. Okay, so if I have 32.0, that's 32 and 0 tenths, which 0 tenths is just 0, so it's just 32. That's what decimals are. Now if I had 2.25, that is 2 and, now these are 2 tenths and 5 hundredths, so I could write it as 2 tenths and 5 hundredths, right? Or I could write it as 2 and 25 hundredths, right? So it's like $2.25 is $2, and then 25 cents is per 100. Remember, cent is like century, it's 100 cents, so 25 cents is 25 hundredths of a dollar. So that's how you would write out these decimals. Okay, so back to our problem here. So now, what if, so 5x times 32, so 6.4 worked as an answer. So what I would do is I would stack 6 of these boards together, and then what's 0.4 of a board? Well, 0.4 of a board is just a fractional part. It's 4 tenths of the 5, right? So I take the 5 inches, and I take, so if I broke it up into 10 equal parts, and then I take 4 of them, that's what it would be. So 4 tenths. What is that equivalent to? I could divide the top and bottom by 2, and it'd be 2/5. So 2 out of the 5 inches would be what I need. So I need 6 boards. 1, 2, 3, 4, 5, 6. And then I need 2/5 of a board, which would just be 2 inches off. Like I'd have to take my table saw and cut it right, slice it down the middle, and then glue that on. So then this would be 5 inches, 5 inches, 5 inches, 5 inches, 5 inches, 5 inches, and 2 inches, which would make 32, right? 5, 10, 15, 20, 25, 30, and 2 makes 32 inches. Okay, so that's one way to think about it. Now, what happens when I have something like this? Take 1 foot, and now I want to split it up into 3 boards. Okay, so I'm going to split up into 3 boards. So, and say I want to split it also this way into 3. So I'm going to take 1 foot and split it up into 3 boards. So 1 foot, and now I'm going to divide it by 3. How much of a foot is that? Okay, as a decimal now, well, actually, feet is also represented in inches, isn't it? So how about we do 12 inches split up into, so how do I change that into also an equal amount? How about multiply by 4? So, or no, 3, 12, 12, there we go, 12, 36. Okay, and then let's reduce this fraction a bit. So I want to make this into a 3. Okay, so if I divide it into 3 parts, so now this is 4 inches out of 12 inches. And that's an equivalent fraction, right? So that's equal to the 1/3 that I wanted. So 4 inches out of 12 inches, so 4 inches, 4 inches, and 4 inches makes 12 inches, right? So, or 1 foot. So it's easy enough to do splitting 12 up into 3 equal parts, right? So that would be 4. But what if I wanted to split 1 meter up into centimeters? Well, this is 100 centimeters out of how much? Okay, so this one's a little trickier, right? If I split up 100, let's see, if I do, how about 30, 30, 30, this is the kind of the guess and check model, right? I'm checking to see if my solution works. So 30 plus 30, no, that's 90. That's not equal to 100. So how about I equally split it up by doing 33, 33, 33. Well, that equals 99, still not to 100. So what if I went 34? 34 plus 34 plus 34. So what's 34 times 3? 12, 9, 10. So 102. That's too big. Okay, so what I have here is 33 times 3 is 99. That's too small. And I have 34 times 3 is 102. That's too big. So it's something between 33 and 34. Okay, so one way we can find our solution is to say, well, what if I had 3 times some number, right? So 3 times some number is going to be equal to 100, right? So what number is that? Divide, if I undo this multiplication, now I could have undone the multiplication before, right? I said if I want to undo multiplying by 5, I could divide by 5. 30 divided by 5 is 6, and that gives me my solution, right? Or if I do 5 times some number is 32, if I divide both sides by 5, I get 32 divided by 5, which 5 goes into 36 times with 2 remainder, right? And the 2 remainder just goes back, so it's like 2/5 that get left over. So 6 and 2/5. And then 2/5 is equivalent to 4/10, isn't it? If I multiplied the top and bottom by 2. So that's another way I could have got my answer, is undoing the multiplication by dividing. So what if I did that here? If I undo this multiplication by 3, if I divide both sides by 3, then I get x equals 100 thirds. But I want to get some kind of decimal equivalent of that. So the way I can do that is do some long division. Okay, sorry folks, we had a problem with the audio. So what happened, so we've take 100 divided by 3. The way you can think about dividing to turn it into a long division problem is if you think of a man riding a horse. A man rides a horse, then the man can go inside the house, but the horse has to stay outside the house. So that's one of the easy ways to remember how it looks when you do long division. Okay, so the 100 goes inside the house and the 3 stays outside the house, and then 3 goes into 1 no times, but 3 goes into 10 3 times. 3 times 3 is 10. Subtract a 9, or 3 times 3 is 9. You subtract the 9 from the 10 that got brought down, and you get a 1, and you see that this pattern will repeat itself continually. And when you get to the end of the 33, you can say, well, then there's remainder 1, so it's 33 and 1/3. But if you want to get more decimals, you can continually add on zeros, as many as you want. The zeros that you add on are just like 0 tenths, 0 hundredths, 0 thousandths, 0 10 thousandths. You're not really changing the number by adding on more decimals. So each time 3 goes into 10 3 times, which makes 9, and then you subtract and get a 1 and bring down the next 0. So this pattern will repeat itself into infinity. This is what we call a repeating decimal. So 33 and 3/10 plus 3/100 plus 3/1000 plus 3/10,000, and it would just go on and on. So instead of writing all those numbers out, we just put a little bar over the top and call that a repeating decimal. And when it doesn't repeat itself, we call it a terminating decimal. So our 32/5, which was 6.4, has an end to it. And we could write as many zeros if we wanted to make it a repeating decimal, but these zeros don't change the value of the number. so we just drop them off. So that's what a terminating decimal is. Okay, so since this has a pattern, it is still considered a rational number. We're going to look later at irrational numbers that don't have a pattern in their decimal approximation, but I just wanted to show you a couple of examples of rational numbers, and we're going to go ahead and do some more conversions between fractions and decimals in the next video.